Oh, hi, I didn't see you there. My name is Chandler, and today I'm here to show you a proof. A very fun proof. A proof for a formula you probably have had drilled into your brain and you completely hate. I'm talking about the quadratic formula here. So for those of you that don't know, the quadratic formula is a way to solve second-order polynomials. A second-order polynomial takes the form of this. You have ax squared plus bx plus c equals 0, where a, b, and c are coefficients. In this case, we'll assume they're members of the real numbers. The idea here is we have solutions in which we can plug in a number x such that this equation is equal to 0. And those solutions will eventually take the form of x equals negative b plus or minus the square root of b squared minus 4ac, and all of that is going to be divided by 2a. Our goal today is to derive this formula from this equation. We need to define another concept, and that's going to be completing the square. And to complete the square, what we're going to want to do is we're going to want to find a way to get any polynomial down to a polynomial that we can factor. The idea here is we'll want to start with something like this. We'll have alpha x plus beta, and that's going to be squared, which is going to just equal alpha x squared, and that's actually going to be alpha squared, plus 2 beta alpha x plus beta squared. Does everyone understand where that comes from? So our next step is to look at this and try to get it to look like this as much as possible. So really fast, I'm going to rewrite the top equation we have here. So we have ax squared plus bx plus c equals 0. Right now, I'm staring at these two and realizing nothing there is the same except x. So I'm going to define some things really fast. We're going to let a equal alpha squared, and we're also going to let b equal 2 beta alpha. And with this change alone, we can already bring this down to alpha squared x squared plus 2 beta alpha x plus c equals 0. And while this isn't exactly the same as this, it's closer, which is our main goal here. So what we can do next is we can do some magic. And that magic is going to take the form of this. We'll go back to alpha squared x squared plus 2 beta alpha x plus 0 plus c. And that's still going to be 0. And this 0 is our main step here. Really fast, I'm going to move us over here. So now what we're going to want to do is we're going to want to rewrite this. But 0 is boring. 0 isn't going to get us there, unless if we pick 0 very well. So what we're going to want to do is we're going to want to start with alpha squared x squared plus 2 beta alpha x plus, and this is where we add in 0. We're going to add in beta squared minus beta squared. The proof is trivial and left for the viewer to prove that this is 0. That's also going to be plus c and equal to 0. Now we can rearrange this a bit. So we have alpha squared x squared plus 2 beta alpha x plus beta squared minus beta squared plus c equals 0. And right here, what we have is the same as we had back here, which means we can substitute straight in here that alpha x plus beta squared minus beta squared plus c equals 0. So it's come to my attention that this equation is actually wrong. This squared right here should not be connected to the b, it should be connected to the entire term in the parentheses. So now once we fixed that, what we can do is we can say from back here, alpha is equal to square root a, and then beta is equal to b over 2 alpha, which is equal to b over 2 root a from this substitution. So now what we can do is we can substitute these two back into this equation, which will allow us to get it in terms of our original variables back here. This will give us the quantity square root a x plus b over 2 square root a squared minus b squared over 4a plus c equals 0. This comes from the squaring of beta here. Now what we can do is we can come back up here and start solving for this. We're trying to solve for x in this case. So what we can do now is we can start by moving these over to the other side. So we'll get square root a x plus b over 2 square root a quantity squared is equal to b squared over 4a plus c. And now what we want to do is we want to get this as one fraction. So what we're going to do is we're going to get a common denominator here. In this case, the fastest way to do that would be to multiply c by 1, or in this case, 4a over 4a. So that's going to give us b squared plus 4ac. Correction, because this was positive over here, it's actually minus c there. So it's going to be minus 4ac, and all of that's going to be over 4a. Now what we can do is we can account for this squared here by taking the square root of both of these terms. So what we're going to do really fast, because we square rooted a square, the things in the parentheses are all that's going to be left. So we've got square root ax plus b over 2 square root a is equal to the square root of b squared minus 4ac all over 4a. And what we can do now is we can say that's going to be equal to the square root of b squared minus 4ac divided by, and now we're pulling this 4a out from under the radical, which means we need to take the square root of both of those terms. The square root of 4 is 2 in this case, and the square root of a is the square root of a. So now we can look at these two, and we can add this to this, or subtract b over 2 square root a from both sides in this case. What that'll give us is the square root of ax is equal to square root b squared minus 4ac over 2 square root a minus b over 2 square root a. And now, because these both have the same denominator, we can just combine the numerators in this case. And by the commutative property of addition, since this is actually square root b squared minus 4ac plus a minus b, we can move the minus b to the left and add this to it. So that'll give us minus b plus the square root of b squared minus 4ac divided by 2 square root a. And really fast, it's important to mention the square root of a term can be either positive or negative. Both of them will return valid answers. So in this case, we can actually use a plus or minus here. Now what we can do is finally, we can divide both sides by the square root of a. So what that's going to do is that's going to give us x is equal to minus b plus or minus the square root b squared minus 4ac divided by 2 square root a, and all of that's going to be divided by 2, or just square root a in this case. And what that's going to do is that's actually going to be moved into the denominator here, multiplied by our current denominator. So that's going to give us minus b plus or minus the square root of b squared minus 4ac divided by 2 square root a, or that's just a, which is exactly what we have up there, and we have a nice little proof. Happy face. Good. Your cup of tea.